Okay, now we're going to go through the next stance known as chicken standing. It's one that I learned in doing Xing Yi. Remember, I do this out of my own curiosity. I'm not a doctor, expert, physical therapist, or any type of professional, so check out the references that I leave and learn for yourself. Okay, so I'm going to walk through the joint positions in this posture, starting from the top and then going down. First thing you notice is that the chin is up, and you see a little bit of that cervical lordosis in the neck, so that's a neck extension. We have some external rotation in the forward shoulder, elbow flexion, basically less than 90 degrees between the forearm and the bicep. The forearm itself is fully supinated, and the hand is in a closed fist, so the fingers are in flexion. Looking at the trunk, we see scapular protraction once again, same that we see in Santi and Tiger standing. Here we have an emphasis on trunk rotation, bringing that in this picture here, it's showing the right shoulder pointing forward, so we have a strong trunk rotation. The raised leg, hip is in flexion. We have knee flexion. In this picture here, the foot should be closer to the knee, raised, and then we have ankle dorsiflexion, so the toes are pulled up. In addition, we have some posterior pelvic tilt, or once again pointing that tailbone downward, maybe even tucking it under a little bit. Now, building upon the joint positions, we'll go through the muscles involved in achieving each of those joint positions. Neck extension is accomplished via the sternocleidomastoid muscle. External rotation in the shoulder is the infraspinatus and the teres minor. The shoulder is raised, which activates the anterior deltoid. The supinator muscle is what supinates, as its name implies, the forearm. A elbow flexion is accomplished via the bicep, and strong supination also results in activation of the bicep as well. Going to the scapular protraction, that involves the serratus anterior and pectoralis minor muscles. And for the trunk rotation, we have the internal oblique on the side of the rotation and the external oblique activated on the opposite side of the rotation. The pelvic tilt activates the gluteus maximus, and the hip flexion is accomplished via the psoas muscles and the rectus femoris, which is a muscle that crosses both the knee and the hip joint. The knee flexion, especially if you emphasize bringing that foot all the way to the standing legs, a knee, will activate the hamstring muscles, the muscles on the back of the leg, and the dorsiflexion of the ankle activates the tibialis anterior. Okay, moving on to tension lines, we have two views here, one that shows more of the front of the body and one that shows more of the rear of the body. So looking at the front, I have the dashed green line showing forces or tensional forces going across the back of the body and then traveling along the tricep into the forearm. This tensional line follows the antagonist action of the supination of the forearm and the elbow flexion. The yellow line here follows the tension in the glute from having the knee hip in flexion and travels along the top of the thigh, then transversing over to the back of the calf down to the foot. Now, the way tension goes through the thigh could be more along the IT band, in which case it will follow down the middle of the thigh laterally, and then moving along to the calf muscle on the back of the leg. It's hard to tell, but the thigh and the lower leg are both covered in fascia. The fascia of the upper thigh is referred to as the fascia lata, and the IT band is a reinforcement of that fascia. And the psoas, quadriceps, glutes all tie into this fascia and also serve as an origin for the IT band. Now, looking at the other image that shows more of the rear of the body, we see some of the familiar tensional lines that we saw in the Santi and tiger posture. So we have the red line representing the stretch across the rhomboids and serratus posterior, and then the blue line showing the stretch along the erector spinae muscles due to the pointing down of the tailbone and that round shape in the back. Here we see the yellow line more clearly shows the tension going from the glute across the lats, down the tricep, and then up the forearms, ending at the fist. I've chosen the tension lines based on the muscles or areas that are in a lengthened position, or the pretty much follow the antagonist actions of the muscles. So in the case of the scapular protraction, the serratus anterior and pectoralis minor are the agonist muscles, which are activated to pull the scapula forward. So the tension line or areas that are lengthened are the rhomboids, serratus posterior, and the lats. Another way you could look at it is to follow the tension in the muscles that are activated, or the agonists. I chose not to do it this way. I was unable to find a continuous line going from hand to foot following that kind of path. Another reason for emphasizing the muscles that are lengthened, or the antagonist pathways, are that most power movements consist of a stretch then contract. So the tension lines are identifying the stretch before the contraction or release of energy. An example would be throwing, a pitcher throwing a fastball. Generally, you'll see the pitcher step out, stretch backwards, and then snap their whole body forwards. So there's a lengthening action preceding the agonist action of throwing the ball. Another example is the coiled position that a sprinter takes before taking off in their sprint. There's a hip flexion, knee flexion, ankle dorsiflexion, and then at the start of that very first step, you see what's referred to as triple extension. So you see hip extension, knee extension, and plantar flexion in the ankle. Here's the references I use to break down the joint positions and the muscles involved in those joint positions, and also the books I use to understand the fascia connections of the muscles along the body. If you haven't checked it out already and you're interested in fascia, I recommend the first reference there, Functional Atlas of the Human Fascial System. Buy that book if you're interested in fascia. Like, share, and subscribe.